I think in the last class we discussed about the types of friction. Here we are having the limiting friction. Firstly, limiting friction. Okay, and then we are having the static friction. Static friction, and then kinetic friction, and then we are having the rolling friction.
Sir, your voice is breaking, sir.
Here we are having the types of friction. Okay, okay. Before the types of the friction, okay, here we discussed that whenever an object of mass m is placed on a horizontal surface, such that this surface is a rough surface. This surface is a rough surface having a coefficient of friction as mu. Having a coefficient of friction as mu. Okay. Whenever we apply a force, okay, we can apply either pushing force or pulling force, whatever it is. Okay. With respect to this, pushing force or pulling force, we'll have an acceleration of the object, right? Okay, fine. Now, if you draw the free body diagram, okay, from the center of the object vertically downwards, we are having the weight mg, and here the object is in surface, is in contact with the surface. See here, the object is in contact. There will be a contact force will act. Okay, that means surface is acting a force on the object. So the force which is acting perpendicular to the surface of contact can be called as normal force. That means this force is acted by the surface. This force is acted by the surface. Okay, is acted by the surface on the object. On the object. Okay, fine. So this is the normal force. Whenever a force is acted, F is the applied force. Whenever a force is acted on the object, here object is moving relative to the surface. So, according to Newton's third law, for every action, there is an equal and opposite reaction. Surface will also act a force on the object. That means this force opposes the relative motion of the object, and this force we are calling as frictional force. The opposing force which opposes the relative motion of the object. The relative motion of the object can be called as frictional force. Okay. Okay. Small f, it is the frictional force. Small f is the frictional force. Okay. Capital F, it is the applied force, or we can call it as driving force. Applied or driving force. Okay, is it fine? Jahnavi,
Yes, sir.
Snehita, antena?
Yes,
Okay.
sir.
Now here it is case 1. Here it is case 1. When the object is at rest, when the object is at rest, there is no applied force, so there will be no motion. Okay, there will be no applied force, hence there will be no motion. Okay, whenever there is no motion, there is no case of obstructing the relative motion of the object. Okay, okay, fine. Next, case 2. When object is in equilibrium, equilibrium means what? Stationary, Shravanti,
Yes, sir.
equilibrium. Equilibrium means what?
Interest.
All
Akashu,
forces are balanced.
All force balance.
Applied force is equal to
other forces
frictional
are
force.
balanced.
Equal, sir.
Applied force equal to frictional force. Sri Harshita, Sri Harshita, Neha, Bhuvan,
Equal state
Om
of
Lakshmi,
force is zero.
Sir, net force is zero.
Yes, sir.
Amma, Aha, Dhanvirka, Mallokasari. Once again,
Net force is
once
zero.
again. Aha, net force is zero. Under which condition net force will be zero? అసలే మెయిన్ పదాలకు వదిలేస్తారు అసలు మీరు. When net force will be zero? Nikita,
When forces
Sujana.
are equal and opposite in direction.
ఆహా, మళ్ళీ ఒకసారి గట్టి చెప్పండి అసలు.
When forces are equal and are in opposite direction.
Equilibrium means that when equal and opposite forces are acting on an object, then net force will be zero. Net force will be zero. When net force is zero, we can say that net acceleration is zero. So we can say that this position can be called as equilibrium. Okay, equilibrium is defined as when equal and opposite forces are acting on an object, then net force acting on an object will be zero. Net force acting on an object will be zero. So that net acceleration will be zero. Net acceleration will be zero. Okay. Okay, fine. Now here it is that net acceleration is zero. That means equal and opposite forces. Applied force is equal to the frictional force. When applied force is equal to frictional force, I can write it as applied force. According to Newton's second law, applied force I can write as MA. By definition of coefficient of friction, we can write as mu is equal to F by N. Can I write? By definition of coefficient of friction, we can write as mu equal to F by N. So F is equal to mu N, right? So here it is, I am writing it as mu N. In this example, see, on a horizontal surface, okay, the normal force is balanced by
Wait.
normal force is balanced by Manish,
mg.
MG, sir.
MG, sir.
mg. Instead of normal force, I can write it as mg. That means mu mg.
Yes, sir.
So whenever the object is in equilibrium, okay, we can write as acceleration is equal to v, right?
Yes, sir.
Object in equilibrium. Okay, fine. Now, okay. Suppose next case, that is case 3. When applied force is greater than the frictional force. So here I can write the net force that is equal to applied force minus frictional force. Can I write? Okay. You can see here applied force, it is moving towards right. That is parallel to positive x-axis. So I can write the, in terms of vectors means F net is equal to F I cap. Frictional force is acting parallel to the or towards left or parallel to negative x-axis. So I can write as plus F minus I cap. So F net bar equal to capital F minus small f times I cap. Antena? Is it right? Snehita? Antena?
Yes, sir.
Force equal to applied force minus frictional force. Okay. So due to the, according to the Newton's second law, we know that net force is equal to motion of, so acceleration of the block I can find as F minus small f by ma by m, where here the small f, it is the frictional force acting on the block when the block is in motion. When the block is in motion, so the frictional force acting on the object when the block is in motion can be called as kinetic friction. Can I say kinetic friction? So this I can write as applied force minus mu k times n by m. That is acceleration is equal to F minus, that is applied force, n normal force means normal force
mg.
mg అంటే mu k mg by m, right? Okay na? So acceleration is equal to F by m minus mu kg. Okay na? Completed. Okay na? Is it clear? Om Lakshmi? Om Lakshmi? అంతేనమ్మా?
ఒకసారి కేసు
చూడండి.
మళ్ళీ చెప్పరా?
Case 3. When applied force is frictional
వాయిస్
force.
బ్రేక్ అవుతుంది.
Hello?
సార్ మీ వాయిస్ బ్రేక్ అవుతుంది సార్.
Okay. When applied force is greater than the frictional force, then we can say that when applied force
Sir,
is
ఇంకా
greater than
break
the
అవుతూనే
frictional
ఉంది
force.
సార్ బ్రేక్ అవుతుంది సార్ మీ వాయిస్.
Hello? Hello?
Yes.
వినిపిస్తుందమ్మా?
Yes, sir.
క్లియర్గా ఉందా?
Yes, sir.
సార్ క్లియర్గా ఉంది సార్ ఇప్పుడు.
When applied force is greater than frictional force. Suppose let us consider I'm having an 2 kg block. Okay. Applied force I'm applying with 20 Newton. Suppose let us consider I'm having a frictional force 8 Newton. Okay. Resultant force acting on an object I can write as, or net force I can write as 20 minus 8. Hello.
Sir,
Hello.
still it is breaking, sir, in middle.
Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Suppose I'm having an applied force as 20 Newton. Frictional force as 8 Newton. Net force I can write as 20 minus 8.
Yes, sir.
Yes, sir.
So net force I can write as applied force minus frictional force. Okay. Now here I'm having the frictional force whenever the object is in motion. Whenever the object is in motion. Okay. So acceleration I can write as applied force minus kinetic friction by m. Force minus kinetic friction. Right?
Sir, it's breaking, sir.
సో వాయిస్ బాగా బ్రేక్ అవుతుంది సార్.
సార్ అవును సార్ మీ
Break
వాయిస్
అవుతుంది
బ్రేక్